Hi all, today in this video we are going to see the types of grammars. So please subscribe my channel so that you could get all the videos regarding the TOC questions. Okay, so types of grammar. So this type of grammar, type of regular grammar is on the basis of three important things. So the first one is on the basis of type of production rule, and the second one is on the basis of number of derivation trees, and the third one is on the basis of number of strings. So on the basis of type of production rule, so it is type 0, type 1, type 2 and type 3. And this is also called Chomosky hierarchy. On the basis of the number of derivation trees, it is of two types, which is ambiguous grammar and then unambiguous grammar. So on the basis of the number of strings, it's two types. There is recursive grammar and non-recursive grammar. In this video, we will be seeing the Chomosky hierarchy, that is on the basis of the type of production rule. The remaining we'll be seeing in our next videos. So now, I told you this Chomosky hierarchy is nothing but type 1, type 0, type 1, type 2 and type 3, right? So now we are going to see the Chomosky hierarchy. So what is Chomosky hierarchy? So in the Chomosky hierarchy, we have four types, and the first one is type 0. So this is called unrestricted grammar. So this type of grammar can be recognized by the Turing machine. So as we know already, all the production rule will be in the form alpha tends to beta. So for the type 0, though it is an unrestricted grammar, it has few rules that needs to be followed in order to make sure the production rule is in the form of type 0. So alpha tends to beta. So the alpha should be either with 0 or more. Variable is nothing but non-terminal, t is nothing but the terminal. So the alpha can have 0 or more non-terminal or terminal, that is star is nothing but 0 or more. And also the beta also should be with the 0 or more terminal or non-terminal. For example, for the better understanding, so I told you alpha should be 0 or more terminal or non-terminal, right? So you have S, capital S, which is a non-terminal, AB. So you have one non-terminal and one terminal. And in beta you have 0 non-terminal and you have a terminal. Okay, I have two terminals. So it doesn't mean that the terminal and the non-terminal should be there. So 0 or more non-terminal or terminal can be there. So when you come to the type 1, that is called context sensitive grammar. This is recognized by the linear bound automata. So if a grammar production rule should be in the type 1, then it should be of type 0 first of all. Then only it can be a type 1. As I told you, it can be recognized by the LBA, which is linear bound automata. And here for alpha and beta, it should be one or more terminal or non-terminals. Also it have a rules at alpha, that is count of alpha should be less than or equal to the beta. For example, you have S that tends to AB and also the other production rule where AB tends to ABC. Here when you see that you have a one non-terminal, and here you have a two non-terminal. So the alpha is 1 and beta is 2. So the alpha is 1 and then the beta is 2. So alpha is less than the beta. Also you have the one or more terminals or the non-terminals. Okay, so here also two non-terminals you have. So 2 is less than the beta, which is 3. So when you come to the type 2, which is a context-free grammar, it can be recognized by the PDA, that is push-down automata. And if a grammar should be, if the production rule should be of type 2, then it should be of type 1, then only it can be of type 2. So here in the alpha, you have to make sure that the alpha is having only single non-terminal, that is either A should be there or beta should be there or C or D, whatever the capital letter should be there in the alpha side, that is in the left hand side. And also I told you type 2 should be of type 1. In type 1 we already have a rule that alpha count of alpha should be less than or equal to beta, right? So type 2 also should follow that. So alpha count of alpha should be less than or equal to beta. So if you have this example, yes tends to AB, so you have 1 here, you have 2 here, 1 is less than 2, and also you have A which tends to A. So this equation can be written like this: A tends to A and then A tends to epsilon. So what is this epsilon? This beta is, you can have 0 or more non-terminals or terminals, 0 or more. So 0 means you can have a epsilon. Okay, so now the last one is type 3, which is a regular gram, which is called the most restricted grammar also. This can be accepted by the finite state machine. So as I told you, if it's type 3, then it should be of order type 2. So then obviously then the left hand side should be of only a single non-terminal. Also the count of alpha should be less than or equal to beta. Okay, so all these rules also is applicable for the type 3, whatever the rule you have for type 2. So here you have, for example, x tends to AA. So you have a single non-terminal and you have a AA where it is 1, which is less than beta. Also this can be written like this: x tends to AA, this is one equation, and x tends to A. Okay, so here also you can see that you have a non-terminal, and then the left hand side you have a single terminal, whereas alpha is less than or equal to beta, right? The condition should be like that, right? So here you have one non-terminal which is equivalent to the beta, because beta also has one non-terminal here. Okay, so the count is equivalent, where it can be accepted in the type 2 restrictions, right? So I hope you all understood the types of grammar. So if you understand my way of teaching, and if it's good, please subscribe. I'll be putting all the videos, further videos, in my playlist.